the sea level in Hong Kong 100 years later will rise by more than 50 centimeters. We assume the situation will get worse in the future, so we decided to design our underwater KK Leung building. We designed an underwater wall that can provide illumination and oxygen. We will synthesize fluorescent marine bacteria with filamentous algae using biologically modifying technology. The final product will be self-sustainable, as the algae would photosynthesize to provide the bacteria with oxygen and nutrients, while the light emitted by the bacteria could be used by the algae. The water system will be sandwiched between the two layers of algae. We would like to rebuild the wall of the new KK Leung building. The outer surface of the building will be reconstructed as a circular shape to resist water pressure. The external surface will be coated with a smart material that applies the lotus effect in a way that it achieves self-cleaning as shown in the video. Learning from the adhesive power of sea barnacles, we would like to add in structure to the underground foundation to stabilize and strengthen the base of the building. Steel structures with the form of barnacle protein layers will be installed to the base of the underground floor. The adhesiveness of the structure will be adjusted depending on the strength and the direction of the water current. A new set of way will be used to lay out the rooms on the lecture floor. The lecture rooms will be laid out in a similar way as beehives, where rooms are separated three-dimensionally in a hexagonal structure. A new type of chairs will be designed. The skeleton structure of the chairs will be made up of the lightest material on Earth, the carbon aerogel. The chairs will be grown out of sponge, which emits vaporous chemicals that could be used for purifying the air. Technology imitating the gecko feet will be applied to the backside of the chairs, so that the seats could be fixed onto any surface, including the ceiling and the wall. An electronic arm developed from the elephant trunk will be installed into each seat, which help in holding up the personal belongings of the students. We would apply technology called the Gore-Tex membrane, which mimic mammal skin to the walls of the floor for the floor temperature regulation. Like the layered mammal skin, the membrane has a thin layer with billions of tiny pores that prevents the large water particle from entering. Despite being water repellent externally, it allows the releasing of excessive water vapor to the surrounding to regulate the internal humidity. The layered structure can help preserve heat. The lecture room is then kept warm and dry. A new set of heat generation system will be applied. We learn from the mechanism in Arctic bees, which are capable of raising their body temperature regardless of the changes in their environment. The shivering movement made by their flight muscle creates heat. We design a heat generation center that will shiver to create heat, and the center will be sandwiched between different lecture rooms to minimize heat loss. A water tension-driven air pump could be developed for mimicking the air transport mechanism of water lily. Water lily make use of its respirational pool generated by photosynthesis to draw fresh air from the water surface to supply its roots with oxygen. Using similar mechanism, energy collected from the sun by the solar panels could be used to pump air into the lecture floor.